abroad. And just say that, oh, you are from a country where Professor Swaminathan is there, and Professor Swaminathan's name come with agriculture. So we feel always very proud of that particular name attached to Indian agriculture and globally. So the next slide shows that agriculture is a journey, the time immemorial, and it goes on from ancient time, 10, 20,000 years back, the plant domestication, and started with that and it moves on. And I would show that with you. Next. If you see the pre-green revolutions, 16th and 19th century, particularly this area, very much that agriculture started working. Transportation, fertilizer, these are all being given or added to the agriculture. 40 and 70, where is the actual development of agriculture took place, where high-yielding varieties, irrigation, infrastructure, modernization, hybrid seeds, synthetic fertilizer, and pesticides are being given. India at one time was the begging bowl for our food. PL480, some of our senior people know that. And today, even myself also sometimes don't, it's difficult to believe that India today exporting 50 US billion dollar agriculture produce. 50 US billion dollar and expanding, and the projection is very high. No? And Professor Swaminathan, what I said here, would be always remembered for his smiling face with the success of driving the policy for achieving food and nutrition security in India and played a significant role in national and global agriculture improvement. The background building is MS Swaminathan Foundation. Here is some of the pictures, not the nice pictures, but to show that even a few hundred years back, or even say 70, 80 years back, Bengal famine, 1943, it was mentioned in the morning, that this was our scenario in India, where although Professor Amartya Sen does not believe that it was lack of food production, Bengal famine, it was because of distribution, which is still today is prevailing. And that's a different things. But scenario that people suffered because of not having enough food. This is a Indian agriculture perspective, that 50% plus population depend on agriculture, but their gross GDP is only 17%. That means agriculture-related dependent people are not doing that well in economics. 140 plus minus the million hectares total agricultural land, which is decreasing. Still, the number shows 140, but I believe that it is much less today. And the record, the food production happened in last year, and projection is continuously this will improve, which is a good thing. But bad thing is 42% of our women and children are still malnourished, which is a very striking feature. Science, as I always say, is global and neutral in nature. It is up to us how we can use it for our better improvement. Fortunately, we had the Prime Minister, first Prime Minister, who always will be remembered for this statement. Everything else can wait, but not agriculture. So that was emphasis given to Indian agriculture. Right, that Norman Borlaug on the left, C.S. Subramaniam, the agriculture minister at that time, and M.S. Swaminathan, who implemented the entire things in the country. And Professor's plan of action I have written here, something, if you read it, then you will see that. What happened that he got to know that Norman Borlaug developed a variety of wheat, which is growing in Mexico and the US, and the material are also sent to the then Pakistan, right? That was India, actually, Lahore. and giving high yield. India is struggling at that time with a very low yield wheat as well as cotton production. So that was the thing. Swaminathan at that time was in the policy, in the IRI director and DGICR. So he proposed the government that we should immediately get this material here in India. And the material, he wrote a letter with the support from the government of India, and then the material, about 18,000 tons of seeds of improved material came to India directly, were grown in different parts of India, mostly in the northern part of India at that time. He understood the genetics, he understood the genetic or genetic molecular biology, so he understood also the genotype versus phenotype, interaction with phenotype. And that's the reason he wanted a lot of India so that the right genotype can be chosen for its multiplication, etc., etc. And that was that key mind that Jonathan had and utilized in our agriculture. These three men for the young people to know they're all 1 decade difference of age. Norman Burdock was 11 years older than Swaminathan. Gurdev Kush on the left is 10 years junior to Dr. Swaminathan. Like Swaminathan and Norman Burdock did for wheat work in India, Gurudev Ghosh and Henry Beecher work in India. Gurudev Ghosh and Henry Beecher and others supervise that also came to India and very nicely, and later on Ratna and many other material developed from that. So these three people played a significant role in achieving the Green Revolution. Please, you have to be alert. Swaminathan and on our right, the man is Ismail Serageldin. If you have any chance to listen to Ismail Serageldin, you would love to listen him many times or every time. Such a wonderful man, wonderful policymaker. He was a vice president of the World Bank, good friend of Swaminathan. Anything he organized in Egypt, I happens to be 3 times I went there. And Ismail and Swaminathan also many occasions that Ismail Serageldin came to India and arranged that attend that meeting. Swaminathan was a key architecture of the Indian policy, scientific policy, particularly along with agriculture. In many occasions, many sort of key sort of positions and the key sort of interaction he always happened and he interacted. This is one of the Indian Science Congress. It happened in Calcutta. If some of you have attended, I had a prime minister, then prime minister had interaction with a galaxy of people, including Professor Swaminathan, and they wanted that science should be given freedom, and that including genetic modifications and as nuclear energy. The policy cannot be developed by democracy, or the policy cannot be based on that what most many other department of West Bengal they will organize throughout the year. Also a good friend of Swaminathan. I happen that I met them in many occasions, and that is another interesting thing that the plant science development. Here, some people are by Professor Swaminathan. That CGI, AR, GFAR, and then FAO, and all the people or the who are in the different kind of positions could play a key role for the agriculture. They always get together and interact and move forward. Now here are a few slides, 2, 3 slides I kept, which is mainly to show from where Professor Swaminathan moves from his date of birth or born in Tamil Nadu and 1926. And then onwards, if you see that how he grew up, particularly his PhD is Cambridge University, England. First time he met Norman Borlaug at University of Wisconsin, Madison, US. Incidentally, that year I was born. And when he met Borlaug at that time, the next slide you see, he was head of botany department of III. Can you imagine? he is also partly a person that he is so much attached to plant science. So at that time, IRI genetics department actually was a botany department, and which is we all know that plant science actually is the mother of many different disciplines and subjects today. He was the head of the botany department of IRI, gradually moves to director IRI, then DG ICR, etc., 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 keeps moving DG, ED, and so and so. And then further, 1983, then founder president of National Academy of Agriculture Science, MP, Rajya Sabha, president IUCN, chairman National Commission of Farmers of India, that he played a very important role. Today, all the MSP and everything that you see, or the government has adopted his policy, and that's the way the farmers benefit are so much significant today. That's because of his chairman commission's report. Chair World Food Prize Laureate Selection Committee for 1 decade. Normally, World Food Prize Laureate are referred as Nobel Prize for Agriculture and Food and allied subject. And he not only he received that award, but he was the chairman for 10 years of that prize. Uh, Further chair even Food Congress, General President Indian Science Congress, President POAS Conference, coordinator the Hunger Task Force of the UN Millennium Project, where many of you are familiar. Still gone, the list is so big, and you can continue to talk on each one of them, you can continue for a long time. But the, one of the thing, number 7, the Time magazine named his name is one of the 3 members who are the most influential people from Asia, and that is Tagore and Gandhi. His name comes. So these 3 names. So his name is with Tagore and Gandhi in the same status. That's the family. It's a wonderful family. If you ever visit his Swaminathan Foundation or any meeting, he has 3 distinguished daughters and who held high positions in India and internationally. And so he had a wonderful family that in his own personal level. Now here I start the journey of the agriculture, that what I'm going to talk today. So you can see the population that today and in 1900 and 1960, 1900, 1960, and 2023. So if you see the change of population, India today 1.4 and world population is 8.1. Indian the production on the cereals, that also you see that is a tremendously significantly it has improved and increased. Same with the world production. So the first time that India is now catching up the productivity and in many cases doing very well as parallel to the Borlaug when he accompanied Borlaug in traveling all over India, the wheat metals to be grown and evaluated them. Prime Minister Indira Gandhi's one statement is very important that no nation can live with pride unless it has the capacity to feed the people, its people. So Nehru, then Indira Gandhi. There was a stamp development, Green Revolution was successfully taking place in India. 1951, 1968, the production is so high, so that the stamp in honor of this Green Revolution was published. So, in International Genetic Congress, 1983, professor is sitting with Mrs. Gandhi. That is the year that is 1987 receiving the World Food Prize, and then on the left with the and then here the Prime Minister, Mr. Vajpayee and Dr. Baroda and other people that in other occasions And here is another occasions that where Indira Gandhi Rashtriya Ekta Puruskar was received by Professor Shamanathan with from Manmohan Singh, B.P. Pal Centenary Award to Professor. And this is where Shaminathan, as a chair of the World Food Prize laureates, is giving the awards to different three plant biotechnologists, world famous plant biotechnologists, Mary Chinton, Trale, and Mark Montagu. So these are the important recipient and the picture of plant biotechnology. Jenny Borler, the daughter of Norman Borler, that was always often many also give the award to BGRI award to Professor Shamanathan. Here are some of the pictures that you might know that the Charles Darwin, Mendel, Watson, Amartya Sen, Tagore featured also here, Mahalanobis and Norman Borlaug and Shaminathan. They all play very important role in discovering science, understanding the science, and moving the science for the human mankind. And for every aspect, they're all integrated today that what we have achieved in India for in agriculture. Prashant Mahalanobis, if there is a chances come sometimes, I might talk Prashant Mahalanobis and Tagore's interaction. On the left side, that you see the tall variety, the present day modern variety of rice. Before Norman Borlaug, there is another scientist who made a significant work for the Green Revolution. That name is Dr. Orville Vogel, who initially first developed a particular variety of wheat coming from Norin, the dwarfing genes, and which is potentially 10 ton per hectare. But Borlaug also used it as a potential system. So that's sort of things that what developed for the rice as well as for the wheat green revolution. Here is again you see the beta, one of the tall variety, DGWG is another variety. Crossing of these two variety developed the IR8. And actually, what later on that we showed that is one single gene, dominant gene. At that time, when people are doing, they are not knowing why it happened like that. Later on, we showed it in rice as well as many other scientists showed it in rice as well as in wheat. There is one single gene, either SD1 or SD1. That gene make the differences, and where this gene expression of that gene reduce the apical dominance of the plant, giving multiple tillers and high yield. Now today, this is the rice scenario that from 1900, you see 1900, 1930, 50, continuously, I told you that in the beginning, that agriculture is a continuous journey. Just if you see an example of rice, how the improvement took place along with the trades. And it's further I'll show in later part of my presentation, further development. Here, some of the people, basically, they're directly and indirectly linked to the rice improvement, and they got all World Food Prize. Headed by M.S. Swaminathan, and last Monte Jones from Africa, and Yang Longping for hybrid rice from China. Now, as I mentioned about the two genes, two dwarfing genes, SD1 and SD1, and later on resulting higher food production in every aspect of the crop. Here is one example of wheat. If you look there again, 1850, 1875, 1900. 1925 is a plateau, so there was no improvement. 1950 onwards, it started. And then today, you see the difference is very big because incorporation of biotechnology and other tools that all integrated now today in agriculture. So that we can see and predict a much faster way of crop improvement. Here is one example of Indian scenario. That was a UK scenario or world scenario. This is Indian scenario. If you look at similarly the same up to 50, 60, there was no improvement. Later on, improvement started. Dr. Raja Ram, great wheat breeder working at CIMET, he got one of the prize in 2014, and many such varieties developed directly from CIMET, as well as Indian agriculture scientists also made a significant contributions on that. And today, only not the variety, but the molecular breeding work or the marker resistant breeding and other transgenic and all other breeding work helping directly incorporating those traits. Here is one example of leaf and stripe rust resistant gene incorporated by ILI scientists, and you see that, and many other BGI scientists also globally, that shows that rust resistance today is possible. Here is the one field in the Philippines. Two of my representative good researcher worked with me. Here is a field of rice full of stem borer. I give one example. Here is we developed one variety that shows leaf folder and other insect pest resistance. The control material shows the leaf folder in the field. The transgenic material in the same field shows total resistance. This is definitely is a joy. I showing a picture of myself while visiting China and seeing the field, and this is wonderful to see that when you are attached with certain work and you see the product of that work in the field and working, uh, that joy you never can forget it. And this is the things that I believe that scientists who work in the laboratory when something achieved, something you see the first result. Same with the golden rice, same with the first transgenic rice that when I was at that time ETH Zurich, the midnight night we first made our SPT assay and found that SPT gene is expressing and inheritance. So that sort of things a joy. And in science, that joy and passion is very important to driving you to do more and more work. Here is a field in Kerala where bacterial blight is a disease of rice. You see, the entire field is devastating. And Gurudev Ghosh, who showed first that IR BB 24, a material that he incorporated with crossed with the material that has the bacterial bite resistant genes, and the dominant gene works for bacterial bite. Cornell group cloned that